Hello guys, welcome back to our channel. Today's video is as usual interview experience of Texas Instruments, but this one is my favorite. Multiple videos are exceptionally good on this channel. I am saying this because if you are preparing for an interview or even if you are a student, these videos will give you the exact structure of preparation you need to follow during your masters or bachelors. So you should definitely watch these videos to prepare for interview. You will get a clear idea about how to plan out things in whatever remaining time you have for preparation. So even if you are preparing for X company, watch videos from other companies as well and prepare notes about important topics to cover, important resources to be used and plan out things accordingly. Now talking about this one is my favorite because while discussing with Bhuvnesh, I felt like he had great knowledge about analog. He planned out things by understanding his strengths and weaknesses and aced his interview. But the main key point is that he was very polite and humble during the discussion. In this video, he discussed in detail about what topics are important for each subject, which books he used for a particular topic, and also about online content he used. He also discussed how he planned his preparation along with practical tips. Video is little bit long, but I am sure it will be worth your time. Comments down below your appreciation for Bhuvnesh. Thanks.
My name is Bhuvnesh Tarachandani. I am placed in Texas Instrument as analog design engineer. TI came to our college for four profiles: software profile, embedded profile, analog profile, and digital profile. As I was very much interested in analog profile and I am from microelectronics branch, so I chose analog profile. And though I was selected for both the profiles, analog and digitals, but I chose analog profile. So the major recruitment process was three parts. One was written test, then interview round, and then HR round. In the written test, they had three sections: analog section, digital section, and uh, aptitude sections. In analog section, they had 20 questions for 45 minutes. In digital questions, they had 20 questions for 45 minutes, and in aptitude questions, they had 20 questions for 30 minutes. The time limit was very less in aptitude, but the questions was also easy. Like in analog section, the difficulty levels was bit high, and in digital section, the difficulty level was bit low. If I say the difficulty level was analog in analog was from moderate to difficult. Like there were questions which were easy, and there were questions which are too difficult in analog sections. So if we talk about the marking scheme, there were +1 for every correct answer and minus 0.5 for every wrong answer. So this was the basic overview of the recruitment process which was carried out in our college. If we talk about the aptitude section, it had mainly questions from ratio and proportion, time and work, allegations and mixtures, speed, time, distance. Like there were questions from pipe and cisterns also, and in time and work area. So there were questions from paragraph. If we have to we have to read the paragraph and we have to answer some few questions based on that paragraph. So such kind of questions were there, and also there were questions from logical reasoning portion, which was quite time consuming. So if one can if one is feeling the difficulty in logical reasoning, so they may skip that, as time was very less in aptitude section. If we move on to the analog section, which was quite difficult, and also it was a bit lengthy because the questions were from moderate to difficult level. Now the major concepts which was covered in the written examination was concept of CMOS buffer, like what is the input impedance and what is the output impedance of CMOS buffer. One should know that, and the questions were there based on that concept. Like next, there were questions from time constant calculations, like how we should calculate the time constant for the complex network. There were capacitor, inductors, resistors in that network along with the CMOS buffers, and we need to calculate the overall time constant uh, for that particular network. Next, there were questions from input and output impedance. It may be the circuit may containing the amplifier, or it may contain the op-amp circuit, and we need to calculate the output impedance and input impedance, these kind of things in that circuit at every frequency range, like low frequency as well as at high frequency. So next, there were questions from quality factor in network analysis. So we need to calculate the quality factor of parallel RLC circuit, series RLC circuit, and also there were questions from time constant of series RLC and parallel RLC circuit. And there were questions, there were 2 or 3 questions from oscillator topic, and we need to calculate in that the oscillation frequency by applying the Barkhausen criteria. So one should know how to calculate the loop gain, because after calculation of loop gain only we can calculate the oscillation frequency by Barkhausen criteria. So there were questions from based on that. Next, there were questions on diode circuits, in which along with the diode circuit, the circuit also has passive elements like resistor, capacitors, and inductors. The questions were like, what is the voltage at a particular time instant at a particular node? They will ask such kind of questions in this area. And there were also questions from high frequency analysis of amplifier. In that, the major topic was Miller's approximation. The questions were very much difficult also of Miller approximation, and one should know how to apply the Miller's theorem in any particular circuit with having feedback. So there were also questions from op-amp circuits, like how we can calculate the output voltage or output current or any node voltage we can calculate. So questions were there based on that. And also there were questions on positive feedback applications of op-amp, negative feedback applications of op-amp, like rectifier, clippers, clampers, and positive feedback applications like Schmidt trigger, astable multivibrator, monostable multivibrator. So one should be thorough with the ideal and practical op-amp model. So this was the analog section part for written test. Now if you move on towards the digital section, the digital section was from easy to moderate. Like the major area in the digital section was basic digital electronics concepts like counters, registers, and there were also sequential circuit, any kind of sequential circuits they could ask, and combinational circuit also, like multiplexer, decoders, encoders, parity encoders. Such kind of concepts were covered in the written test. Next, there were also questions from Verilog HDL. There were 1 to 2 questions from Verilog HDL. There were basic questions. One can answer easily if the basics are clear. Now there were also questions from concept of driving strength. Like by driving strength, I mean the sizing of MOSFET, how we can increase the output, how we can increase the output time constant or decrease the time constant by varying the width of the MOSFET. So such kind of questions were also there. And there were also questions from noise analysis, like there is a glitch and how we can reduce that glitch. So and there were also questions from capacitive coupling noise, inductive coupling noise in the digital written test. There were also questions from finite state machine analysis. It is a very important topic for written tests as well as interviews. And there were also questions from CMOS inverter and its noise margin analysis. So one should thorough with CMOS inverter. They can ask anything from this topic because it's very important topic for written tests as well as for interviews. Like characteristic, output like output time constant, input time constant. They can make any combinational circuit from the CMOS based logic, and they can ask any sizing of the MOSFET or time constant of the MOSFET. And there were also questions from FIFO depth calculation, and metastability, how we can remove the metastability by using synchronizers. So all those questions were covered in the written examination of digital section. So the questions were very basic. If one is thorough with the basics, so they can clear the written exam very easily. So the main key point in the written exam was speed and accuracy. In analog section, since it was a difficult as well as quite lengthy, so one should be thorough with the basics and one should maintain the speed along with the accuracy in analog section. And in digital section, one should thorough with the basics as well as speed should be maintained. In aptitude section, one should practice more and more questions because the domain of aptitude question is very, very large. If you move on to the written exam preparation, so in aptitude, I majorly prepared it from gate notes. Basically, you can prepare from any resources. There are ample amount of resources present on the YouTube. So the major work in the aptitude was question practice. One should practice more and more questions. So we can also practice questions from India Bix, and there are many other question banks, gate question banks and gate previous year questions. So this was the aptitude preparation which I which I did. And majorly in analog section, I prepared it from GATE syllabus. The one should thorough with the GATE syllabus, entire GATE syllabus, so of analog electronics. And I preferred a book named Sedra and Smith, for it is a good book for undergraduate analog electronics concepts. I prepared the high frequency and low frequency analysis of MOSFET and BJT from that book, and also op-amp configurations from that book. Also, there is a concept called time constant analysis. So it is very nicely covered in that book, Setter and Smith. So the next book I preferred was Razavi, CMOS Analog Design by Professor Razavi. It is a like textbook for our MTech AICD course. So I preferred that book mainly for differential amplifier, oscillators, and feedback concepts. And also, one should also watch the Professor Razavi YouTube lectures of both electronics 1 and 2. They are very much important. They will give you the confidence in the concepts of analog electronics. And he covered each and every concept in a great detail. So next, CMOS analog CMOS from the Kang book. It's a digital book, which is very great book, and the concept of CMOS is given very nicely in that book. And I prepared network analysis from Gate notes. The network analysis is basically the prerequisite of AICD, so one should be thorough with the entire network analysis concepts. Like there is a YouTube channel named Champion T. Professor Champion T is also a professor in the is a professor in the BITS Pilani. So their YouTube lectures are very nice, and for basically for RC circuit, RLC circuit, LC circuits, so and other network analysis concepts. So those videos were very helpful, and he gave very much intuitive analysis, very good intuitive analysis for every circuit. So one should watch that lecture. So, and there is a YouTube lecture by Professor Ali Hajmiri, California Institute of Technology. He very well explained about the op-amp designing and bandgap reference circuit, so which were very much helpful in my project, which was asked in the interview as well. So if you move on to the digital section, the major digital portion was covered from GATE syllabus. I prepared GATE syllabus very thoroughly and practiced previous year GATE questions. And if we talk about the next preparation, YouTube lectures by Professor Janki Raman was very much helpful. He gave very good explanation on digital VLSI design. It is present in the YouTube. You can watch that. And next, Verilog, concepts of Verilog, I covered it from Professor Indralin Sen Gupta, IIT Kharagpur. So those lectures were very good, and it was very helpful for my interview as well as for written test. Like next, I prepared VLSI design subject from two books, Rabe and Kang. So for Rabe, I mainly studied sequential circuit and combinatorial circuit, and from Kang, I studied memory design and CMOS inverter concept. So these were the books which I preferred. And there is a channel called VLSI Expert. I prepared the static timing analysis from the VLSI Expert website. He gave very good explanation of each and every concept. So one should also practice the questions which he explained, although they are a bit difficult. But those, if you are thorough with those questions, so the written questions would be very easy for you. So these were the preparation strategy and the various concepts in the digital area. If you move on to the technical round, I had only one round which lasts for around 1 hour. So he mainly asked me about the various analog concepts, as it was a analog design interview. So he mainly started from my project. Like he started me that what is my project was on folded cascode differential pair with common mode feedback along with gain boosting. So he asked me to draw the folded cascode circuit and how it is different from the conventional differential pair. And he also asked about the design procedure which I followed to design that circuit. And then he asked me to like how you choose the W by L ratio for each and every transistors. He asked me that. And also he also asked me about the how you choose the current and voltages at each and every node and branches, and also how you decided the output swing and power dissipation constraints, how you manage those constraints. So he was asking those concepts. Like then he asked about the problems which I faced in that project, and how I rectified those problems. Basically, he also asked about the causes of that problems. So mainly I mentioned one cause, like there are second order effects in the transistor. So the very next questions he asked about the what are those second order effects. So I told him that there are DIVL and the various velocity saturation concepts. So then he asked about the what is DIVL, drain induced barrier lowering. So he was asking about the device physics. He keep on asking about the device physics then thereafter. Then after discussing about the project for around 25 minutes, then he moved to the concept of feedback circuits. As I mentioned in my resume that I designed a gain boosted amplifier, which is the application of negative feedback. So he was very much curious about the feedback concepts which I had. So he started with that how we can decide whether the particular feedback is a negative feedback or positive feedback. He started with this question, and then he gave me a diode connected MOSFET and asked me to justify that it is a positive feedback or it is a negative feedback. So I justified it that it is a negative feedback using the loop gain concept. So one should be thorough with these concept, how to calculate the loop gain and how we can decide the feedback nature of feedback by using loop gain concepts. So next he gave me an op amp circuit where there were both negative feedback as well as positive feedback. Then he asked me that what is a dominant feedback in this circuit and how will you reach that that which is a dominant feedback. So I explained the entire procedure, like how we can calculate the feedback factor at each inverting and non-inverting terminal, and what is the nature of feedback. Based on that we can conclude. So these were the concept from feedback he asked me, because I exclusively mentioned in my resume. That's why he was very much curious about these concepts. So next he moved on to the RC circuits. So where the RC circuit is a very like interesting topic for them. They like this topic very much, RC circuits, and also impulse response of RC circuits. They gave me a low pass filter and they keep on adding the capacitors here and there, like any random place they will add capacitor and they will ask you to find the response, current response, voltage response, and its frequency response analysis, and how you can calculate the poles and zeros intuitively. And they also asked me that how you can reach to the response without having the circuit, just by having the Bode plot. So he asked me to give the response expression, mathematical response expression using just Bode plot, nothing else. So these were the questions from RC circuit and RL circuit and RLC circuits. They also asked about the second order circuit like LC oscillators, and in feedback also they asked about the oscillators. Like they asked one question that whether the negative feedback can become unstable or whether the positive feedback can become stable. So I answered that question, and he asked me the condition for that particular stability condition for every for each feedback, negative as well as positive feedback. So then he asked me about the application of positive feedback. So I told that there is an oscillator design. So then he asked me to like draw a circuit of Wien bridge oscillator. So these were the concepts from oscillators and RC circuits. Then he moved on to the op amp circuit. He gave me a simple basic op amp circuit and asked me to write the output expression. So I wrote the output expression using superposition theorem. So it was a very simple questions, like it was a like gate syllabus. It was from gate syllabus. Like then he gave me the one question from network analysis, like a simple circuit having voltage source, two voltage source, and one resistor, and asked me to find the current in that loop. So it was a very simple question he asked me. Then this was the interview experience for analog profile. Like and also they are very much curious about the project which I done on SRAM. Later they also asked me how did you implemented the sense amplifier, because I wrote exclusively the sense amplifier mechanism. So he asked me what is the working of that particular sense amplifier and how it is amplifying that input voltage, input small excursions which are applied at its input. So he basically, it was a differential pair, so it is an analog circuit only. So that's why he asked me about that circuit. So in basically to uh, like the interviewer was much interested in my approach. It was not like mandatory to reach out to the answer always. So there were many questions which I couldn't answer, like when he asked me to draw the Wheat bridge oscillator circuit, so I drawn. But then he asked about that, if we interchange the RC combination, then what would happen. So I couldn't answer that question. So there are various questions which I couldn't answer, so it's okay. Like they don't want your final answer. They are just watching your approach, thought process. So one should also very much crystal clear about their concepts, and one should also explain explain the concepts in very crystal clear manner. So this was the interview experience for my analog profile. After technical interview round, I had a HR round. Basically it was just a formality round, and he asked me about my future goals and why I am interested so much in analog design, why I'm not interested in digital design, as I was placed in, like, I cleared interview of both profiles. So he asked me about what all projects I had done in analog design. So since I was aspiring this analog profile and this particular company from second year, so from second year of my BTech, so he asked me about that, like what projects did you done in BTech, and what all seminars and what all workshops have you attended on in this particular area of analog IC design. So he was very much curious about project and my interest in this field. So this was a question which he asked in the HR round. So after that, my interview got over. Then like I would like to give some tips based on my past experience, that as I started the preparation from my second year, when I was preparing for gate. So I covered the analog electronics very briefly. And because TI was a company where the actual practical knowledge of the engineering is used, so that's why I was aspiring this company from the second year of my BTech. Like, so that's why I covered digital concept of digital electronics and concept of analog electronics very thoroughly from my BTech days only. So when I entered in this college for MTech Bits Pilani, so here I got like around 1 year of time to prepare for my interviews, like for to prepare for the company. Like we had company in July, so I had around 1 year. So that's why so I started preparing for the interviews since my first year of my MTech. So people usually start their preparation before 2 or 3 months. So that was a like a wrong approach, I think so, because the syllabus of for analog design is very large. Like it has like one should thorough with digital as well as analog if we are applying for analog profile. So that's why I started preparing for this analog IC design and digital IC design from my first year of my MTech. So the like that was the uh, like timeline of my process, like timeline of my how I approached this company and how I was preparing for this company since very long time. So like I would like also give advice that one should use a technology. Like I was using a pen tablet of Wacom, because it was a pandemic situation. So interviewer was very much exhausted, like we need to write on the paper and we need to show on the camera. So interviewer was like feeling exhausted. So that's why I bought a pen tablet by Wacom. So I was just sharing my screen and I was writing on the tablet, and he was just watching that and also asking questions. So he was more curious about the asking questions because of the easiness. So this was my interview experience. And also I would like to give advice that one should explain their answers by using diagrams. Like you don't explain by like in air or in without diagrams. You should use diagrams and flowcharts to explain your concepts. And one should also uh, speak out your thoughts. Don't solve on the paper and at last show them on the camera. Just solve and just dictate your steps, what you are following, what all steps you are followed to reach that particular answer. Because interviewer is more like focused on your approach rather than your final answer. So this was the basic uh, like my interview experience and few advices from my side. Thank you and all the best.